Hello students, welcome back to geometry. Today we are going to be talking about the SAS theorem. Now, the reason that we have the SAS theorem is because in our last unit we had triangles. We were trying to prove that triangles were congruent. I'm going to draw slightly more obviously scaling triangle. There we go. And just because I can, I'm going to copy this and then paste it so I know that I have a truly congruent triangle. Now, I'm going to call this triangle ABC, and this is going to be triangle DEF. In 5.2, when we were talking about congruent polygons, we said that in order to prove that two polygons are congruent, you have to prove that all of the corresponding parts are congruent. So that means for this set of triangles, I would need to take 7 steps to prove that they're congruent. I would have to show that 3 different sets of angles are congruent, and I would also have to show that 3 different sets of sides are congruent. And then for the 7th step, I could say, therefore, these 2 triangles are congruent. So the SAS theorem is a shortcut that we can use for this, because here's the idea. If I knew that just 2 of the sides were congruent, so if I have these 2 sets of corresponding sides, and I also know that the angle in between them is also congruent, if those 3 pieces are congruent, that implies that everything else is congruent, and therefore the entire triangle is congruent. So, what we would say here is that if 2 sets of corresponding sides are congruent and the included angles are congruent, then the triangles must be congruent. Okay, so you'll notice I typed included angles in all caps. That's very important. If we say that we have 2 sides, the included angle has to be the angle that's in between them. It has to be like this, right here. If this is true, we have a side and then an angle and then a side. We have a side and then an angle and then a side. So that's the SAS theorem, the side angle side theorem. Now, before I go any further on how this works, I would like to illustrate some non-examples. So if I have 2 triangles and I have 2 sides like that, 2 sets of sides that are congruent, and then I have this angle. Now notice that this angle is not the included angle. This is not the one that's in between the 2 sides. It's off to the other side. Now this one would not be side angle side. This one would be angle side side. See, angle side side. So remember that angle side side does not work. It has to be side angle side. In the same way, if I were to move it to say over here, this would be side side angle. And side side angle does not work. So remember, it has to be side angle side, not side side angle, and not angle side side. Okay, so very first one, we're going to prove that triangle ABC is congruent to triangle DEF. And just by looking at this here, I can see that I have 2 sets of congruent sides and then the included angle. This is in fact the included angle. It's between the two sides. So I can use that information to show that the two triangles are congruent. So here's how I do this. I would say step 1. Segment AB is congruent to DE. Reason? Well, it's on the picture, so it's given. That little red mark on the picture means that they're telling us those are congruent. Now, whenever I do this, I take step 1 right there and I put a little S next to it, because what I just did was I proved that a side was congruent. Now, moving on, step 2, I can say angle A is congruent to angle D. And again, it's on the picture, so it's given. Then I'm going to mark this. I just showed that the included angle was congruent. Let's do this again. Step 3, I can say side AC is congruent to side DF. And again, that's because it's on the picture, it's given. So now I've shown that two sets of corresponding sides are congruent and their included angle is congruent. So the next step that I can take is I can say triangle ABC is congruent to triangle DEF because of side angle side theorem. Now, this was a simple proof because all of the reasons were given. So let's do one that's a little bit more complicated. So looking at this one, I have given BC is congruent to DA and BC is parallel to AD. I want to prove that ABC is congruent to CDA. So let's go ahead and get started. Step 1, BC is congruent to DA, and that is given. And again, I'm going to mark right here. I just proved that a set of sides is congruent. Now, step 2, I have BC is parallel to AD, and that is also given. Now, that doesn't prove that anything is congruent. However, I see BC is parallel to AD, and as soon as I see that it's parallel, I can start thinking of all of my parallel line vocabulary, all of those rules that I can use. So, just to see this better, I'm going to draw BC and AD off to the side, with that transversal cutting between them like that, and I know these are parallel. So what I can see is that this angle right here and this angle right here, those need to be congruent because those are alternate interior angles. You see, if I slide that green picture on top of the original picture, I can see that's this angle here and this angle here. So I can say for my third step, angle BCA is congruent to angle CAD because of alternate interior angles. And then I'm going to mark that one with an A because I just showed that some angles are congruent. Now, in order to get the third side, I see that the third side of both triangles, or the other set of corresponding sides I should say, is this one right here. It's the same side on both triangles, so what I can say for step 4 is that side AC is congruent to segment AC. And you'll remember, anytime I say that something's congruent to itself is the reflexive property. So that means that I've proven side angle side here. So now the next thing that I can say is step 5. Triangle ABC is therefore congruent to triangle CDA because of side angle side